that drawing, nobody won, which shows you how unlikely it is to win. Hundreds of thousands of tickets were bought because, I mean, Mrs. Goldring alone bought 5 tickets, and that was $10, or $2 a ticket. But of anything that you'd spend $2 on, this is literally the least likely event possible. Let's check this out. So, do you want to, not build a snowman, but win $1 billion? Here's how you win $1 billion. This is how Powerball works. You choose, I turned it off. But you choose 5 numbers and then a kicker of the Powerball. These 5 numbers, anyone know how many numbers there are to pick from?
I don't even know how to spell
7? No. Wait, no. On the ticket there's 7, but I think there's like...
On the ticket there's 6 numbers actually. You have 5 initial and then the Powerball.
It's 59.
It went up this year. These numbers range from 1 to 69. So each individual number, you have 1 out of 69, or a little over 1% of matching that number. Every new number you add in, you have to multiply by those percentages, so you keep getting tinier and tinier and tinier. This, the Powerball, used to be from 1 to 35, and I had to research all this morning when I decided we'd start class with this. Now they made this a little easier. The Powerball is 1 through 25. So the Powerball alone, you have 1 out of 25 or 4 out of 100. So to match the Powerball, you have a 4% chance to match just the Powerball. Now matching just the Powerball does nothing. You have to have other numbers matched also in the right location. So even if I had like a 16 here, and they pulled a 16, if they pulled a 16 for the first number, my 16 doesn't matter because it's not in the right location. That's why this is so hard to win. Ella?
Wait. Do you guys have a pencil I can use?
There's none in the jar. If you promise I will get this back because it is my pencil that normally stays in my pocket. All right, so here's the regulations in case you want to know. 44 states take part. This is not just Ohio. The first numbers are between 1 and 69. The sixth number is between 1 and 26. Oh, sorry, I said 25 to make the math easy. It's actually 26. So your probability is 1 in 292 million. That, if I convert it to a percent, is 0.0000003%. That is 3 millionth of 1%. We talked about percent smaller than 1. Take 1%, chop it into 1 million pieces. You get 3 of them. That's your probability of winning. So let's compare that to some other probabilities that you encounter every day. This is where math gets fun. Your risk of dying via transportation accidents. Walking. You walking and being hit by a car, a motorcycle, a bus is 1 out of 50,000. If I round, 1 out of 50,000. Because think about it. If you look at how many people get hit each day, like around the, I don't know if this is nationwide or worldwide. It's probably nationwide. I doubt we'd have worldwide data. Your risk of dying on your bicycle, most bicyclists are pretty safe and stay off the road. So that's lower, 1 in almost 400,000. But cars, everybody's driving in cars. There's a lot of traffic deaths every day. So that, your chances are 1 in 18,000. 1 out of 18,000 compared to 292 million. You are more likely to get in your car after school and die than you are to win the Powerball. Let's go on. It gets even funnier than that. Not that dying is funny, but that the probability comparison. No?
I just figured it out. There are 40,460 combinations on
Oh, yeah. Doing the combinatorics. We get there like next year, really. Hold on, I got to keep moving on. Save these questions. So all of these are going to be in the video, so I'm not going to talk about all of them so you can look. So occupant of riding a bus. Now, buses are pretty safe. Even if they get in a crash, you normally don't die. So when you take the bus home, your odds of death on the bus are about 1 in 7 million. I'll take that chance. Think about the people thinking that they're going to win the Powerball, though. They're like, oh, yeah, I'm going to win. they're more likely to die in their car. Or like they're thinking, oh yeah, I could win this. Well, yeah, you could also be in a car wreck and die. Falling from your bed, chair, or furniture. Your risk of dying is 1 out of 360,000. That's not that. That's dangerous. No, it's risk of dying struck by objects unintentionally. So your risk of being caught between two objects is 1 out of 2.5 million. Sharp objects. 1 out of 2.7 million. Your risk of dying in an explosion of fireworks is 1 out of 58 million. Your risk of death from a dog bite, not being bit by a dog, but death from a dog bite, is 1 out of 15 million, almost 16 million. This is funny. Your risk of drowning in the bathtub is 1 out of 800,000.
Fall asleep in your bathtub.
Your risk of suffocating on your food while eating is 1 out of 350,000. Your risk of being bit by a venomous snake and dying is less than 1 in 1 million. You are more likely than 1 in 1 million. I'm going to scroll through the rest pretty quickly. Oh, sorry, billion. Yeah. Lightning strike. So here's what they can start combining. I'll even round up, 1 in 5 million. 1 out of every 5 million people get hit by lightning and die. So if you start looking through this list, you're more likely to, in the same day, be struck by lightning and die, bit by a dog and die, and drown in your bathtub and die. All in the same day,
And get hit by a car.
before you would ever win the Powerball jackpot. So I'm just going to scroll through all the rest of these so they're in the video, and you can go back and pause the video if you want to see any of these specifically. Your risk of poisoning yourself. Hold on. Assault by somebody else. Here, intentional. Oh, sorry, this is intentional. Where was I think there was unintentional. Unintentional injuries. So those, that gets kind of a little bit morbid, so I'm not going to go over that. Risk of being poisoned in your home. So, like, if you're a kid, like, drinking Clorox or something that you, like, is not... Yeah, 1 in 30,000. Which? Oh, I don't know. Doing things dealing with money. Apparently, so risk of dying at work in certain career fields. So, farming is really dangerous. Like agriculture, that's farming, that's really dangerous. Your likelihood of death while farming is 1 in 3,425. Now, remember, some people die like natural causes at work. Like you might work all the way through the end of your life and you might just have a heart attack. Yeah, something like that. So if you are like an accountant, financial activities, you have a 1 in 142,000 chance. So when you're looking at gambling, just think about those probabilities and how unlikely you are to win. You can go buy a Powerball ticket, that's fine, but you are very, 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 very unlikely. Well, okay, so Emmett said his parents are going to buy him one, and if he wins, it'll pay for his college. Like, so
Emmett's not going to college?
They would have to cash it in. Like, yeah, you can't buy one, but also your likelihood of winning is so nil, it doesn't even really make a difference.
I don't think 900 million can pay for college, Mr. Russell.
You don't think so?
No.
You must be going to a pretty good school.
Harvard, Duke University.
Welcome to Equation Chef. Your challenge is to use words to describe or a picture to model a real-world situation that relates to the equation shown. Your situation must somehow involve the secret ingredient, bagels. Reveal the equation. Go.
This whole chapter, we're in love with bagels. So, here's our equation. 6b plus 150. Now, we, last week, did a lot with taking a verbal situation and turning it into the numerical. Now we've got a numerical situation that I want you to turn into a verbal. So if you think about going to a bagel shop, like Tim Hortons or somewhere like that, what might be something constant that you would purchase? Think about 6b plus 1.50 equals 540. What would these things represent? So what about your 6b? What would 6b represent? We talked a lot about this last week. Jackson?
6 bagels.
6 bagels, and that's probably going to be the price of 6 bagels. So what would the 1.50, what could that represent? If you think about going to a bagel shop, Shahib?
Just a guess, the price of the box.
No, because you're not going to pay for the box. What else might you have to pay for at the bagel shop? Nate?
Tax.
We're going to assume because it's food that they're not taxing us. That kind of goes back and forth on whether you eat there or don't eat there and stuff like that. What else might you buy at a bagel shop?
Coffee.
Coffee. So maybe you bought a coffee that was $1.50. And then what would
Bagel's just a donut with a slice of
what would 5.40 be? Nate?
total cost.
Total spent. And we could solve this, and if we solve this, we would find out that just like last week, our bagels here would cost 65 cents. If Smart would wake up. So, check out. Hey, gentlemen, I need you to stop talking or move seats. I've given you plenty of time to get simmered down, and every time I take a breath, you start talking. So either knock it off or change seats. Check out our first example there. Well, apparently I'm going to come back to this. Our first example there has a company shipping 5 samples to a client. I know this says Math 7, but you guys are Accelerated 7, and it's 11.5. I just didn't want to pull up the other PDF. So what we see is 5 samples are all the same thing. They should all weigh exactly the same. Then we have to ship it in a box, and the box is going to have some kind of weight. Nothing can actually be weightless or massless. And we know the weight of that box, and then we know the total weight when I put it on the scale and I go to ship it is 47 ounces. So we, instead of putting G plus G plus G plus G plus G, just change it to 5G. Instead of putting the weight of the box, I replace it with 8 because I know that. So I want you off to the side here to write, how would I turn this bar diagram into an equation, and then how would I solve it? And then solve for what is the weight of each sample while I try to capture the lunch. You have it on your paper, so while I'm trying to capture this. Okay.
You want us to solve it?
Yeah. If you're confident with your equation setup, go ahead and solve it. Ashton, what is the equation that you used here?
5G plus 8 equals 47.
5G plus 8 equals 47, because we see the width here is the same as the width here, which means they are the same, they are equal. So the first thing we want to do to solve there, Grace, we want to subtract 8 on both sides. Then we will on the right get 39. On the left, we still have 5G. So then, Leah, what do we do to finish solving for G? Precisely. Divide both sides by 5, and we get that each sample's mass, or each sample's weight, my G's sometimes look like 8s, so feel free to ask if you ever get confused.
7.8.
Yep. It's 7.8. What? Dogs, cats, pizzas?
Yes.
What's the weight being measured in this problem? Ounces. So we'd abbreviate that OZ. 7.8 Oz. You know, like the Wizard of Oz. Questions on how we did that? Questions on how we did that last one? So, this situation that won't relate to any of you, you and your friend are playing games online. Many of you are like, yep, okay. You buy one software package and your friend and 3 months of gameplay. Now this is where it's important to read through the whole problem before you start highlighting or underlining. I don't know if I want to group my stuff compared to my friend's stuff or how I need to group these. So continue to read. Your friend buys one software package and 2 months of gameplay. each software package, this, by the way, the software package, that's like the game. Like when you have to like buy the game and then you buy the online play. So each software package costs $20 and the total is $115. So that's as if you were at your friend's house and you ordered all this together. You both went together. You bought the software in 3 months. Your friend bought the software in 2 months. So I want to represent this as a bar diagram. So I already gave you this on your notes. What would we put in here in this box to represent the whole thing? Ella? 115, because I know the whole thing should equal 115. Now, if I go up here and highlight this, I'm just going to start by highlighting one software package in yellow. Is there anything else that should be grouped with that software package? Shiggy? Are those going to be the same? Will like the software cost the same as the gameplay?
Your friend buys one software.
Yeah, you bought a software package and your friend bought a software package. So I'm going to start by saying, okay, I bought software, he bought software. Then I'm going to change colors because it helps my brain. I bought 3 months of gameplay and he bought 2 months of gameplay. So Zach, how would I represent that?
Wait, I think I have the whole thing.
You mean like the equation?
Yeah.
I'll come back to you. So if I just want to start representing this, here's a month. Here's a month. How many months total will I have? 5. So you want to take up the whole thing. Try to be as uniform as possible because every month is going to cost the same thing. So if I turn this into an equation, I need to first replace something. What down here can I replace? Zach?
You can make the softwares $40.
Yeah, so the two softwares combined, this is actually $40 because they're $20 each. Then I still have 5M. And what's that going to equal, Zach?
5M plus, equals 115.
Yeah, so I'm going to capture this, clear it, and scoot over. Off to the right there where I left you that space. If I was you, I'd rewrite it exactly how Zach said. My variable value first, my 5 months, plus my 2 software packages were $40 together, and they equal $115 in total.
And then subtract the 40 from each side, which would get you 5M equals 75.
Uh-huh.
Then divide by 5 on each side.
Yep, then divide by 5. And M equals each month of gameplay is $15. I heard that the PlayStation Network was down for like a couple days the other week, and that's like unheard of. Yeah. My buddy who lives with me was like downstairs hanging out with us, and I was like, "What's going on? Like, you don't normally like hang out that much." And he's like, "Oh yeah, PlayStation's down." I'm like, "Oh, because you can't play online now, you're gonna hang out." I was just grading paper, so I'm boring anyways.
It's like, what's your name again?
Wait, you live up there? All right, try this on your own. Companies relocating. Now, you don't have to draw a bar diagram for it as long as you're comfortable being able to draw a bar diagram. Because your mastery, very well likely, will have one that I ask you to draw a picture to represent. Just so that I know you can take the mathematical and turn it into the visual, spatial sort of reasoning. So we're renting a truck. And this is exactly how it works when you go to U-Haul or Penske or anywhere. You go to rent the truck and you pay a fee. Then you're going to pay a mileage. And you don't know until you get back how many miles you'll actually drive. And before you return it, you got to fill it up with gas. So even though it's not part of the actual price of the truck, it kind of lumps in with what you paid. So a lot of time, well, in the past years, people have asked, that $164.67 includes the gas. So that is everything you paid for the truck. So that $164.67 is the rental fee, the mileage cost and the gas that we put in. Be careful with setting it up like this. And you're going to set it up like that, and you would want this. And then have your 115. I'm upside down. But because even then, it's kind of hard because you stack these and then these are beside it, so it's hard to. That's why we went long ways to show the width of 115 and this is the width. I know you get it mathematically. It's just sometimes hard to draw. Per mile, it's every mile. I drive 1 mile, I'm going to pay 99 cents. I drive another, pay 99 cents.
.99 times.
No, because that doesn't matter. They are charging me for driving, not the gas. They're charging me for driving. So when I rent the truck, like, and I've done this a lot, moving friends and stuff, they write down the mileage when you leave with the truck, and then when you come back, they write down the mileage, they subtract it, find out how many miles you drove, and charge you extra based off how many miles you drove. Because that's wear and tear on the truck.
Burrito.
Sheep?
Can we round up?
No, you cannot round it to $1.
65 bucks. That's a lot of gas.
Not when gas was $4 a gallon. Think about a big old box truck, like a Penske truck. It gobbles through gas.
Did you know
Not
that
fun.
gas price is supposed to go down towards $1 again?
I think all of it is a distraction technique. If gas prices are low, the American populace is happier and we complain about less things.
Maybe.
But I'm a
Maybe
conspiracy
it's
theorist,
Illuminati,
so
yeah, right. I think it's Illuminati.
I really am. All right, who can help me out? What needs grouped? What do I know? What don't I know? How do I set this up as an equation? Going once.
Oh, me.
Okay, Nate, start me off.
I'm not dumb, but I know how to set it up. So what I did was put the .99 cents per mile. So that would be, I just put .99 M.
Yeah, I like starting with my variable value. So I normally ask myself, what is it we don't know? Well, what we don't know is how many miles we drove the truck.
Yeah.
So I'm going to start with the term that relates to that, the 99 cents for every mile. This is where per can mean division or multiplication. Really, that means division, but how we're applying it, we set it up as multiplication, because that would mean 99 cents for 1 mile, and then if we drove 20 miles, we could find our charge. But how we set it up, we just show the multiplication.
And then I added together how much it costs to rent the moving truck and the cost of the full tank of gas.
So I'm going to go ahead and write both out separately just so you can see it. But yeah, then we had the fee for the truck. $39.95 is not bad, bless you. $40 for a day with the truck is not bad. $65.32 in gas. And then we're going to set that equal
To the 164.67 cents.
So when you combined the two constants on the left side, what'd you get?
105 and $105.27.
27.
Yeah.
Because these were both constants. Remember that step before solving? Before we try to solve, we simplify. This is part of that simplification. I can combine those. Why can't I combine those numbers? They are like terms. I can combine them because they are like terms. So then, Olivia, what do I do now?
You have to. Did you already subtract?
We did not yet. So we see addition. We subtract on both sides. Now, what is this number that I'm about to get when I do that subtraction? What does that actually tell me? Because it comes out to be like 59, right? 59, 58, something. I think 59. I think it should end in a 0 because
59.2.
I think it's 59.4. Should be if you do the math correctly. What is that 59.40? $59.40 was what I paid for the mileage. So now I need to figure out how many miles. Class, what do I do?
Divide.
Now, if you've already done the math, you already know what's going to happen. But what happens when I divide by a number less than 1?
It's more.
It gets bigger. So, not by much, but here we get 60 miles. So we drove the truck 60 miles. Now, this is where understanding the math and comparing prices is really convenient. A U-Haul truck is cheaper to rent, but their mileage is more. A Penske truck is more expensive to rent, but their mileage is less. So, depending on how many miles you're going, will depend on whether U-Haul or Penske is better. And sometimes just to steal your business, they'll make special deals for you. So I got Penske to give me a truck rental with no mileage charge.
But it was like $70.
I forget what I paid per day, but it still wasn't bad because I had to drive from here to Coshocton, which is like 70 miles, and then from there back.
It's 140 miles.
Yeah, and then if you think of from Home Depot to my house to Coshocton, back to my house, back to Home Depot, it's like 150 miles. If it was 99 cents per mile, that's another $150.
Oh, Lord.
So if I can do that quickly and not get charged for like as many days, it's a way better deal. So that's why sometimes when you're comparison shopping, you got to do math to be able to compare places with each other.
So does it have like a thing that like tracks?
Yeah, every vehicle has a thing that tracks your miles. It's called, anyone know what it's called?
Speedometer.
No, that tracks your speed.
Mile-
Speedometer tracks your speed.
Mileometer.
Not a mileometer. An odometer. Your odometer tracks how far you've driven.
Oh, so
I want to challenge you guys. I want to see if any of you can isolate the F. We have our formula here for Celsius compared to Fahrenheit. I want to know what we need to do, and be careful with the order, to isolate the F to give me my Fahrenheit formula. So try it on your own. We have Celsius equals 5/9 F minus 32. What all needs to happen to isolate the F, and then what does F equal? So try it for a minute. Remember, we're doing the order of operations backwards. So instead of parentheses coming first, they would have to come last. You could distribute, but it makes it get a little messy. So, like we saw last week, what is the problem trying to make you do? Not if we're trying to solve. What's the problem trying to make you do? Hey, Seth, you're like one thing away from moving. And I'll either move you or Nate, but someone's going to move. You need to shift your desk back over to be behind him, because this is... Okay, we need to stop talking to him then. Because you have not solved this problem at all yet, and you're sitting there probably talking about football or something nonsense. What's the problem trying to make me do? If I was simplifying this, what would be my first step? Yeah, like Karen said, I would distribute, and I could distribute, but I don't want to. But it's a fraction. Zach again, Zach attack. Multiply by its reciprocal, and that will get rid of what it wanted you to distribute, but I have to do it to both sides. So I multiply by 9/5 over here. Also, that leaves me with 9/5 C equals F minus 32. Because the distribution's gone, I no longer need my parentheses. Now my other option would have been I could have distributed, but then I would have 5/9 f minus whatever 5/9 times 32 is, which would be some messy number near 16, 17, somewhere around there. But instead, now all I have is one step left and I'm done. Shahid? Add the 32 to both sides. Make sure we say it to both sides. And because it's happening to the whole side, no parentheses or anything necessary, it's 9/5 c plus 32 equals my f. So here where you have f equals, that should be 9/5 c plus 32. Yeah. You can if you want, but we normally just leave it improper and see what plugs in there and then how that works. Because, I mean, 1 and 8/10 would be like 1.8 c. That's not really any nicer. It's just, if you like decimals better, sure, you can do it that way. I know, this would turn into 1.8, right? Because it'd be 1 and 4/5, which 4/5 is 8/10.
Wait, why wouldn't you just add it by the 32 and make it 33.8?
Because it's 1.8 c. They're still not like terms. Even if I make this a decimal. So what Noah was asking is, could I make this 1.8 c plus 32? Or the other thing we could do with it is make it 1 and 4/5 c plus 32. Either way, they all mean the same. They all represent the same thing. I like improper fractions because they're precise and I can use them. I can put them in the calculator and I can use them. Chief?
I just noticed this. What you're pretty much doing when you do this, just swapping everything on F, like,
You have to be careful because the order it happens. I agree with what you're saying, but when I solve for Celsius, I do my subtraction first, then I multiply. When I solve for Fahrenheit, I multiply first and then add. That's the weird thing about converting back and forth from Celsius to Fahrenheit. What's the third temperature scale? We've got Celsius, Fahrenheit, Kelvin. What's special about Kelvin?
it can reach absolute zero.
What is absolute zero? What happens there?
All particle freeze.
All particle movement
Yeah,
ceases. Particles can no longer move at absolute zero. Do you know what absolute zero is in degrees Celsius?
Zero? Wait, no, negative
500?
No, close. Well, kind of close.
5.
This 0 degrees Kelvin, if I wanted to look at it as Celsius, is negative 273 degrees Celsius. It's negative 273 degrees Celsius. So the distance from freezing to boiling is only 100 degrees. It only takes you 100 degrees Celsius to boil. You're almost 3 times that distance negative to get to absolute zero.
We haven't
It's
gotten to
very, very, very cold. What?
We haven't gotten to absolute zero yet.
No, I don't think in science you guys have gotten
How
there.
is it? How is it like they haven't? How do you get that?
So Kelvin and Celsius share the same scale. 1 degree is 1 degree. We just use Kelvin scientifically because a lot of our measurements happen below freezing. So instead of using negative degrees, they can still use positive numbers to represent very cold temperatures. Because 0 degrees Kelvin is when everything stops. Like no life, no movement, it all stops. So they might say, well, at 200 degrees Kelvin, well, really, that's still a negative. It's below freezing, but they can use a positive number
Wait,
then.
then what would be, like, 0, 0?
So 0 degrees Celsius, which is freezing, is 32 degrees Fahrenheit, is 273 degrees Kelvin. But that's freezing. At 273 degrees Kelvin, you are freezing. So at boiling, the Kelvin for boiling would be 373 because it uses the same scale as Celsius. It's just it's just offset. Now Fahrenheit and Celsius do not use the same scale because between freezing and boiling for its Celsius, simple, nice, 100 degrees. For Fahrenheit, between freezing and boiling, 180. it gets goofed up. That's why the math is so like weird, the 9/5 and stuff. That's why it's so weird. And the plus 32 or the minus 32, that's all happening because of this relationship right there. To get them on an even keel, we have to either add 32 or subtract 32 to get them to match up. That's why we do it in the math.
Is it absolute zero in space?
I don't even think it's absolute zero in space. You have to like force it. I mean, maybe at some point really, really far away from planets or the sun, or you gotta realize our heat comes from our planet, like keeping heat in it and whatever, but and our distance from the sun because it's a star. So it depends on how close you are to a certain star, whether you're affected by that heat or not. Huh?
Pluto's not exactly absolute zero, but it's pretty close. Right?
Yeah, because it's really far away.
Yeah.
Yeah, and that this goes back to the video we watched about the scale of the universe. It's very hard for us to actually realize how much further Pluto is away from the sun than we are. I mean, we're like here, and that's still really, really far, and Pluto's like way far away. Like, hey, bye. Yeah.
That one guy in the corner at the party.
All right, speaking of space, Magellan spacecraft launched in 1999 before any of you guys were born. Took a 463-day flight. I was 10 years old when this happened. To Venus. It was doing research on, this is when we started to really want to know about the other planets. So it traveled 806 million miles in 463 days. So we want to first solve our distance formula for r so that we can then calculate what was the rate. So what's nice is when we have a formula to start with, I can manipulate my formula because my dirt formula is for solving for d. What if I want to solve for r? Well, to solve for it, I would want to get it by itself. How do I get it by itself? What, Ryan?
Divided by t.
Yeah, divide both sides by t so that r is not connected to anything. So r is actually distance divided by time. Think about it. Rate, how do we normally talk about speed here in the US? Miles per hour. Your distance per divided by your time. That's how we find rate. I'm worried about how many people I think are not writing this down. So then if we want to find Magellan's rate, we'll take their distance. I'm actually going to cheat a little bit. I'm going to say 806 and just write million, or like MIL for million, so I can save writing out all those zeros. Or, I guess I'll play by the rules. If you want to write all the zeros, you'd add 6 more zeros. So that's our distance in miles. And our time, let's start by just doing per day. We will get to hours, but first let's just do per day. So when we do this calculation, slightly less than 2 million, because think about it, we have 806 divided by 463. So we get 1,700,000. After that, I don't know exactly what it is.
4082.
Yeah? 1,740,820 miles per day. So if I want to convert that to miles per hour, how would I take that and make it miles per hour? Be careful with this, Ella. Will I travel more miles in an hour or in a day? In a day. So when I'm going to make the math hours, would I multiply or would I divide? We divide. So to convert this into miles per hour, we just take it and divide by the 24. And that gives me how many miles I traveled per hour. It's still insane.
I'm not even.
You got it, Ella?
Wait, 7,254.416.
Wait, 7,253. We'll just round it right there. So guys, this spacecraft was traveling over 7,000 miles per hour. We can't even fathom how fast that is. And it still took 200 and some days to get to Venus. Because then I think it traveled back. I think it was back then we had to get the data and bring it back. I don't think we could send it.
Isn't it like that? Like in space though, like if we were out in space, it would be going really slow.
Well, it depends on your scale. Depends on if you're in the shuttle or if you're watching it from far away. If you're watching it from far away, like when you look up at the sky and there's a comet and you can like watch it and it's slowly traveling, that thing's hurtling through space at like a mind-bursting speed. But you're so far away from it, it looks like it's just moving kind of like a plane. When you watch a plane in the sky, a lot closer to us, but it still looks like it's moving slow because it's still thousands of feet away from you. Normally about 30,000 feet up, between 30 and 60,000. So yeah, we will pick this. I still have 2 minutes. Hold up. We're gonna solve for t real quick. So do the same thing with the dirt formula, except isolate the t. What does t then equal? We should be able to quickly think about this.
So,
If I isolate the t, I would just get rid of the r, so my time will equal distance divided by rate. Funny. So then I can take the total distance they swim, divide it by their rate, and it will take orcas 26,400 divided by 704. 37.5. My time was in minutes up here, so I still use minutes. It takes them. That's insane, guys. They can travel 26,000 feet in a little over a half hour. Well, think about it. If a mile is approximately 5,000, like 5,300, 5,280, then that's about 5 miles. It's a little under 5 miles. So they're really traveling, if we like really approximate, they're probably traveling at like 9 miles an hour or something like that.
They must have to
Swimming.
eat a lot to keep that kind of energy.
Yeah. I have some papers before you take off. I got papers for Jackson, Carrie, James, and Ella. Jackson, Carrie, James, and Ella.